So we have 2340 divided by 38, and this will give us 61.58. So approximately our bar x is equals to 62. So that is the arithmetic mean of this particular information, and this can be put in percentage. So the mean score is actually 62%. The mean score is actually 62%. So from the foregoing, we have been able to look at arithmetic mean for a single set of data, and likewise we have also considered arithmetic mean that is laced or characterized with frequency. So this time around, let's look at arithmetic mean for grouped or interval data. So in some instances, a set of data given to us may actually be put in form of grouping, or may be grouped as the case may be, or better still, the data can be expressed in terms of interval, and this may require us to compute the arithmetic mean for such statistical data. So in a grouped frequency distribution, it is very important to note that all values are being classified within a given class interval, and they are all assumed to be coincident with the class midpoint, or that the interval that is denoted by x. So due to this particular assumption or belief, the arithmetic mean can be calculated by the method to be shown in the example below, and it is not exact but approximate. But in a simple sentence, if we are given such situation, that is, we have our statistical data being given in form of grouped or interval data, then we still have our arithmetic mean to be computed as we have done recently, which is summation fx all over summation f. So only that our x here will represent the midpoint of the class interval given. So that is what majorly differentiates this from the previous formula we have adopted for the purpose of obtaining the arithmetic mean. So we still have our formula as arithmetic mean, which is bar x is equals to summation fx all over summation f. So let's look at example here to derive from our point. If the distribution of loans disbursed to 60 smallholders farms registered under Family Economic Advancement Program in a locality were given as follows: we have loan disbursement in thousands of naira. We have 1 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50, 51 to 60, 61 to 70, and we have 71 to 80. Then we have number of beneficiaries, which include 3, 6, 11, 16, 10, 8, 5, and 1. So the question now is, calculate the average loan disbursement. Calculate the average loan disbursement. This still boils down on the subject matter of arithmetic mean. So I told us that arithmetic mean as well as average can be used synonymously or interchangeably. So as required, we are expected to compute or calculate the average of loan disbursements. But if we are to interpret this, we have 1 to 10. So those that collect 1 to 10, they are 3. 11 to 20, they are 6. 21 to 30, they are 11. 31 to 40, they are 16. 41 to 50, they are 10. 51 to 60, they are 8. 61 to 70, they are 5. And 71 to 80, they are 1. So based on this, we are expected to compute the average loan disbursement or arithmetic mean as the case may be. So it is very important to put this in appropriate table so as to have a clear picture of what the problem is. So we can represent this as class interval. So we have the class interval, and that is 1 to 10. We have 11 to 20. We have 21 to 30. We have 31 to 40. We have 41 to 50. 51 to 60. 61 to 70. 71 to 80. That's our class interval. Then we are given the frequency. The frequencies are, we have 3, 6, 11, 16, we have 10, we have 8, we have 5, we have 1, and the total of this, though we were told is 60, but we need to confirm it. So we have 3 plus 6 plus 11 plus 16 plus 10 plus 8 plus 5 plus 1, and this is equal to 60. So we have this as 60. So that is our frequency. So from this particular class interval, we can get our midpoint, and our midpoint here will represent our x. So how do we get our midpoint? We need to add the two class intervals together and divide the result by 2. Like for example, we have 1 to 10. So we can have 1 plus 10, which is 11, divided by 2. This is 5.5. We write 5.5 here. Then we have 11 plus 20. This is 31 divided by 2. That will give us 15.5. We have 15.5. The next one is 21 plus 30, and this is 51 divided by 2. That's 25.5. The next one is 31 plus 40. This is 71 divided by 2. We have it as 35.5. The next one is 41 plus 50. This is 91 divided by 2. That's 45.5. The next one is 51 plus 60. And this is 111 divided by 2. That's 55.5. Then we have 61 plus 70. This is 131 divided by 2. We have 65.5. Then we have 71 plus 80. And this is 151 divided by 2. This is 75.5. So this represents our x, and that's what otherwise known as midpoint. So the next thing is just to get a column for fx as usual, and that's f times x. So for f times x, we have 3 times 5.5. This will give us 16.5. We have 6 times 15.5. This is 93. 11 times 25.5. That's 280.5. 16 times 35.5. We have this as 568. We have 10 times 45.5. This is 455. We have 8 times 55.5. This is 444. And we have 5 times 65.5. This is 327.5. Then we have 1 times 75.5. That will be 75.5. So let's sum this up. And in summing this up, we have 16.5 plus 9.3 plus 280.5 plus 568 plus 455 plus 444 plus 327.5 plus 75.5. This will give us 2260. So that's what we have. So from there, we can get our arithmetic mean, which is summation fx over summation f. And this will give us 2260 all over 60. So we have 2260 divided by 60, and this is 37.6. We have this as 37.6. So this is 37.6, and approximately our bar x, that average loan disbursement, is 38. So if it is in thousands of naira, that would be 38,000 naira. So the average loan disbursement is equal to 38,000 naira. So that is the solution to that particular question. So let's look at some methods of computation of arithmetic mean. So generally we have looked at arithmetic mean, and we have seen how it is being computed, but it must be noted that there are some other methods which we can adopt in order to compute the arithmetic mean of a given statistical data. and we are still going to get the same result as we have done. So the rigor of computation can be greatly reduced by employing the following two methods of computing the arithmetic mean. And these methods are, we have the method of assumed mean, or we can call it assumed mean method, and we have the use of coded method, or coded method as the case may be. So these two methods, we can easily apply them in order to solve a given statistical data with a view to obtain the arithmetic mean, because it is commonly believed that the difficulty we have actually gone through in terms of computing the arithmetic mean may greatly be reduced when one of these methods or the two methods are actually put into practice with a view to obtaining the arithmetic mean of the given statistical data. So we have assumed mean method and we have the coded method. So let's look at this one after the other. We have the method of assumed mean, or simply put, assumed mean method. So this particular method ensures that we are able to assume a particular value for mean, and based on that we are able to influence the statistical data and get the arithmetic mean using the assumed mean method. So in this method we choose an assumed mean which is always denoted by A, and this is regarded as the value which we are going to expect to be the mean. So in the interval data we have to choose a convenient class midpoint as the assumed mean, judging from the position of the individual class frequencies. And if we have this, we can have an appropriate formula for assumed mean. So the appropriate formula for assumed mean is given as, we have it as A plus 1 over n times EFD, and that is if frequency given, or we can have A plus 1 over n times ED. So the D here represents the deviation. It represents the deviation, and it is difference between the x and A. So D is x minus A, the set of data given minus the assumed mean we have chosen. So that is how to get our D. So let's look at example here. And that this one, if you look at this, we can also have a frequency distribution too. When we have our assuming that has frequency, that's what informs this formula. This is the formula we are going to use. If the question given to us has frequency and we are asked to compute the arithmetic mean using assumed mean method, then the formula is A plus 1 over n EFD. The A here represents the assumed mean. It represents the assumed mean. N is still total frequency as we have known, total frequency, and this is equals to x minus A, which is x minus assumed mean. So we have that our F is total frequency. But if it is not with frequency, or if it is without a frequency, then the assumed mean is equals to A plus 1 over n summation D. So the D still represents x minus A, and we still have our A to be our assumed mean, and n is still the total frequency, or F as the case may be, total frequency. So let's look at this example here. We shall illustrate this method using example 4.1, 4.2, and 4.3 aliasing for non-frequency and frequency distribution respectively. So in this question now, we have the x like the first example we treated. We have 70, 65, 73, 105, 85, 90, 69, 95, 82, and we have the 100. That is what we have. So we are required to compute the arithmetic mean using assumed mean. But they said we should make our assumed mean, our A to be 80. So we are assuming our A to be 80. If that is the case, we have our x, which are given as 70, 65, 73, 105, 85, 90, 69, 95, 82, and 100. That's what we have. So this represents our x. We have 70.